All right, so this video is talking about piecewise functions, but it has a little bit of extra fun to it because it has a couple of extra questions about, here I'll highlight them here, interval of constant. We also are talking about the zeros and what's the difference between a zero and an x-intercept. We'll talk about that. Extrema, we haven't seen that word yet, and points of discontinuity. So those all fancy words there are things that we're going to discuss in this video and kind of break it down, and then I'll do another problem a little bit quicker. So anyway, those are all the things that we're going to be talking about in this video. And let's go ahead and talk about, again, we'll start from top to bottom. We'll start with the domain. Okay, and so for the domain of this graph, you see that there's the graph off to the left, and actually in this lesson we give you the function. We actually give you what was being shown on the graph. But we don't necessarily need it for this particular part to do all this, but it's just nice to have. You'll see in another problem where we actually need the function to actually do all the work we need to do. All right, so the domain of this graph, again, all the possible numbers x can be. All right. Now, we're going to assume, we're looking here, reading this graph left to right, that that part of the graph is going to continue going downwards and outwards, right? If we left it to go on forever and ever and ever and ever, it's eventually going to keep going down and out towards negative infinity, which we can never include negative infinity. There we go. And then the domain, okay, as we're going left to right, it seems that it stops, okay? Now, here's where it stops, here at x equals 1, okay? And you'll notice that there is an open dot, okay? And notice what I'm doing here is that I'm looking at x equals 1. Are there any closed dots, okay? Let's just say, for example, the closed dot was here and this line just kept going up. Then that wouldn't be a place where the domain would stop because there's a closed dot at that point 1. Even though it's jumped somewhere else, that means but the domain would still be continuing. But as it stands, the dot is not at 1, so there's only an open dot at x equals 1. So what that means is we have to stop the domain at 1, and we can't include it because there's an open dot there. Okay? Then the domain picks up at 2, right? So after it gets to 1 and we stop there, the domain starts again at x equals 2. And then as the line continues to go up, it's going to travel upwards and outwards to infinity. Okay? And then we're going to not, actually we can include 2 because it's a closed dot, and we can't include negative infinity. And whenever I have two intervals in the same list, I have to put a union there. Okay? So that was a little bit trickier. So for the domain, it stops at 1, and again, we look at x equals 1 for any closed dots to see if, like, okay, it's not inclusive at that particular point, but it's inclusive anywhere else. But it's not, and then it picks back up at 2, and then keeps going. So that was a tricky domain. Now let's talk about the range. Again, where all the y values, where it's the biggest, or I mean where it gets goes up, and all the y's where it goes down. Well, as we talked about, it's going to keep going down. If we're looking at the left piece there, it's going down all the way to negative infinity. Okay, and then it's going to go up, and it looks like it stops right here, right? Even though it kind of swoops down, it stops at 2. Okay, which we can include. That's fine. Now, when it gets to 2. Notice how there's no other dots in between where that stops and where it continues going. So then it picks back up at 3, which I can include as well, and goes all the way to infinity. So there's another gap for the range because the graph is going up and then it kind of stops and the two pieces of the graph are disconnected and there's nothing happening right here in between the two dots. Because there's nothing happening, I have to stop the range and stop it at 2 and then pick it back up at 3. So there we go. There's the range from negative infinity to 2 and then from 3 to infinity. All right, y-intercept. I've already put a dot there for us, and that's at 0, 2. X-intercept or x-intercepts. Okay, the x-intercept is right here. We'll say that's negative 1.5, 0. Okay, so negative 1.5. And then when it asks for zeros, here's what it's asking. So it's asking for where does x equal 0? So it wants to know the exact number for x. It doesn't want to know the coordinates like we just did for the x-intercept. It wants to know where does the function equal 0? where does the function f of x equal 0? At x equals negative 1.5. So that's what it wants for the zeros. So one of the zeros of the function is negative 1.5, which is the x-intercept there. All right, now let's talk about increase, and this is something we should be very familiar with. Okay, so I can see, let me do a different color here. I see that this is increasing all the way to here at that point, and then it makes a turn. But then the graph will start to increase again from there to there. Okay, so the orange parts are my increases. So where does it start increasing? Again, whenever we talk about increase or decrease, we always use the x number, or the x value where it starts. So it looks like it starts at negative infinity for this one. And it will reach all the way to 0. Now, I know we're tempted to put 2. It stops at 2. But again, we want the x value. The x value where it stops, and 0 is right here. So it goes from negative infinity to 0. And we can include 0. Why not? And then it starts increasing again at x equals 2. And it will keep increasing until infinity. And we can include 2, and we don't include infinity. Let's put a u for union, because I have 2 different intervals within the same list. So I have 2 increasing intervals there. All right, let's talk about decreasing. Okay, so decreasing where the graph is going down, and the only piece that's going down is just this little part right here. So that's a little section of purple right there. Okay, so it starts, and again we want the x value, so it starts at 0 and decreases only until 1. Okay, I can include 0, but I can't include 1 because there's an open circle. So I can't include 1, so we put a parenthesis there. All right, interval of constants. So notice how for the increasing and decreasing, the way I like to describe it is that there's a slope of some kind, right? There's a positive slope, a negative slope, and if it has a slope, then it's increasing or decreasing. But because interval of constant, here's what that means, okay? If it's an interval of constant, that means the line is literally flat. It has a 0 slope. It's not going up or down. It's just simply going across, okay? Now, in this graph, do you see a point of which, again, it's simply just going left to right with absolutely no slope? There's actually not. It has a curve or it has some type of slope on it, so there's not applicable here. There's actually, at every point, it has a slope. Okay, a point of discontinuity, meaning at which x value does the graph become discontinuous, meaning where does it break apart? Well, it starts breaking apart at x equals 1, okay, because right there's the open circle there, and then also at x equals 2, right, because that's where they disconnect. So there's actually an interval where the graph is discontinuous, okay, but it starts at x equals 1, and it also starts at x equals 2. There's a gap in between 1 and 2. So we just write 1 and 2 are the points of discontinuity. And then lastly, extrema, meaning the points of which there's a relative minimum or maximum. Extrema is the plural of minimum maximum. So rather than saying find the minimum and maximum, we just say find the extrema. And so for the extrema, we need to find a place where the graph goes from increasing to decreasing or from decreasing to increasing. And at that point, the graph has to be continuous. So I only see one place, so it goes from increasing to decreasing right here. So the red dot on my graph is the location of the extrema. In this case, that happens to be a relative maximum, and that occurs at x equals 0, right? I know you're saying, oh, what about 2? Now, again, that's the y value. We want the x value. So that was all the different parts there of number 3, kind of breaking down each one of those. Again, I would encourage you, if you're like, oh, I need more time to think about that, you can always pause the video, go back to the section you need. In the next video, it actually makes you graph. Like you're given the function, but you need to graph the function yourself. Ooh, that sounds like fun. So I'll see you there in the next video, but I hope this video gives you a good tutorial on how to use piecewise functions and find all these different pieces of information.